All right, so solving quads. Thanks, Tom and Al. Why do we want to solve quads? Why? We want to find x, and what does x represent? Because what we're heading towards here is we want to actually end up graphing our quadratics, right? Now, you've told me that a quadratic can look like this, or it can be the other way. Yep. Now, do you remember anything from last year about what determines whether it's, can everyone remember what this is called? It's a certain shape. It is a parabola, correct? But it's got a certain shape. Right, so this one is concave. I like to think the bear's in the cave. That's me. Don't poke the bear in the cave by, you know, how do you poke the bear? Don't do your homework. You chat, you come late. Concave. Right, and yes, this one is convex, concave, convex, little terms that we should know by now. When we are going to graph our quadratic, there's some key features that we want to be able to label, and it helps us to solve it. So, let's say we have this one. When we solve a quadratic, it is these things here and this here. What are they? They are your x-intercepts, okay? And that's what you are actually finding when you solve a quadratic, okay? Sometimes it might be that you're finding where two things intersect, and yes, that's when you're solving that too. But for now, when we do this, we find our x-intercepts. What's another key feature on our graph that helps us sketch it? The y-intercept. And hopefully we go, yeah, baby, that's pretty easy, because how do we find our x-intercepts? You're making y equal to 0. Do you agree? That's why we get everything on one side, make it equal to 0. Well, how do you find your y-intercept? You make x equal to 0. There's a couple of other key features on your diagram that we want to also find. Can anyone remember what they are? Right, what is the max, or in this case the min, what is that called? It's got a special name. Pardon? P? No. TP? Oh, peak. No. So we've got the max. We've got the min. Ah, love it. We've got the vertex. It's also referred to as the turning point. Right? And we've got one last key feature, and it's part of, I would say, the vertex / turning point.
Axis of symmetry.
Love it. The axis of symmetry. So, oh, no, we want the color coding. Oh. Okay, so this thing that goes right down the middle, that is called your axis of symmetry. So, the stuff that you were doing overnight and last weekend, factorizing, quad form, and completing the square, and I'm assuming we haven't finished the quad form yet, correct? Right, that is helping us find our x-intercepts. Hopefully today, we're also going to look a little bit at using some of the stuff to find our vertex. I don't know if we get to that, but we'll see. There's so many things with our functions that it all comes together. Can we come back to the concave and convex? How do we know just by looking at the equation if it's going to be concave or convex? If what's negative? They go, if it's negative. No, I could have a negative y-intercept and it's convex. The A, and that's called the leading coefficient. Okay, so remember we talked about any quadratic is a x squared plus bx plus c, and you have to actually say a can't equal 0, right? Now when a is greater than 0, so we're starting to use maths language and notation. So when x is greater than 0, that's when it's convex. When a is less than 0, it is concave. Is there anything else that a tells us? The dilation. So similar to when we had the sine and the cosine graphs. Remember the a out the front? That stretched it, made it skinny. Yeah? Well, that does the same thing here. So when a is large, right, that means you're going to have a reasonably skinny parabola. And if it is less than 1, so a half, a quarter, it gets quite wide. So these are just little things, because eventually you're going to get to the point where it's going to ask you to sketch these graphs. And I ask students all the time, yes, what does this mean? If it's less than, it means it's concave, and lo and behold, I'll get them to find the x-intercepts, find the y-intercepts of minus something, and they draw me convex. I'm like, what's going on? So make sure that we do understand. So that's where we're heading with all of this. Oui? And of course, we're going to have some optimization problems where we find the vertex. All right, so let's have a show of hands. How did we go with the completing the square? Did we get to it? All right, so some people being honest, that's lovely. We didn't. So I think we'll just reverse some of the orders around, because some people did do completing the square. We don't want to bore them silly. So that's okay. Just a quick refresh. So we can do these in any order. Wow, who's that? I will come back and read about them. So the quad formula, let's be honest, do you need me to go through that with you? What about simplifying surds? Do you remember how to simplify surds? Okay, so let's just pick one. All right, so we already know, hopefully, like we're not worried by this, because we know the A, the B, and the C. Well, the A, in this case, what would my A be? Yep, A would be 1. B would be? -4, right? So don't just go 4, let's look at the sign in front. And of course, C is going to be -3. And it's just a simple matter of now whacking it into our formula, right? Do you have to write this down? God, no. Right? It's up to you. If it's maybe you made some mistakes last year or you don't remember it at all, well, you might want to, but you'll see that you'll get quite into the... I'm running out of room. My teacher always made me write the formula because it just flows. It's also then, I'll do it. It's also then right there, and you are less likely to make a substitution error. Okay? We're all good? So, minus B, so -4, which means it's just 4. Plus or minus, I should have left a line there. I will rewrite that. Whoop. So, -4 becomes 4, plus or minus, okay, B squared. Now, here's where we make a little bit of a deal. That if you ever tell me that -4 squared is -16, you have to give me 10 push-ups. Same as if you ever tell me -5 squared is -25, 10 push-ups. What happens when you square a negative number? You get a positive. But why do you think I get people telling me that it's a negative value? Right, they don't use their calculator properly, right? So when you do it on your calculator and you say -4 squared, your calculator is doing exactly what you're asking it to do. It's doing the exponents first, then it's sticking the negative in front, and that's why you get -16. What you should do, and you get the right answer. I personally don't ever even bother. I just know when I square a negative, I get a positive answer. So I just put 4 squared in. Your call, but I swear I will catch you and I'll make you do 10 push-ups. Seeing as I can't even do 1, but anyway. So I'm going to put 4 squared minus 4 times. See, I don't even put minus 4 squared. Why? Because I know it's going to be a positive answer. Minus 4 times 1 times c is negative 3. All over 2 times a, so 2 times 1 is 2. So we go plus or minus 16 plus 12. Now, we're going to do this without touching our calculator, because remember, we're going to have a non-calculator part of the test, and this one is clearly a great example, Al, you with us, for what could be in the non-calculator section. The numbers are small, it's nice. We carry on, we say 4 plus or minus, right? It checked, negative times a negative gave you the positive, 1028. Here's my question to you. Can I divide each of those by 2? Barbara. That's a no. By the way, if you're listening at home, everybody went yes. Not everybody, but a lot of people went yes. So you can't, right? If it was 4 plus or minus 28 over 2, absolutely you could divide each one by 2. But because you've got that square root, no, Nanette, you have to simplify it first. So this is when, you know, stuff starts getting a little bit complicated. We have to remember a few other things. So let's just recall what you have to do to simplify a surd. You have to look for a square number that goes into it. What are my square numbers? 4. 7 is not a square number. Oh, I see. You're saying 4 sevens. Right. 4, 9, 16, 25, 36. It's starting to get quite large. It's probably doubtful that any of those, right? So basically a number that I know the square root of, correct? So yes, for those who said this is the same as 4 times 7. 4 sevens are 28. And that means I can split that to be root 4 times root 7, which gives me 2 root 7. Yeah? And of course, I could have said, well, isn't 28 the same as root 2 times root 14? Well, yes, it is, but I don't know the square root of 2, and I don't know the square root of 14. That's why you have to make sure that it's a square number that you select. If there is no square number, we say, huzzah, less work for us. We good? Huzzah. All right, so this becomes 4 plus or minus 2 root 7 over 2. And now you can divide each term by 2, because 4 divided by 2 is 2, and 2 root 7 divided by 2 is 1 root 7. Yes? If this was in your calculator section, but it said show algebraically, well, there you go. And then you would check using your calculator by doing what? We go menu, we go equation, polynomial. We used this before? Hell's bells. Polynomial, degree 2, and you just put in your coefficient, so ax squared plus bx plus c. So what was our... So 1 minus 4 minus 3. So we pop in here 1 minus 4 minus 3. And it even gives you your exact answers. Now, the older calculators will not give you the exact answers. That's a bit of a bugger. I should try and find one of my old ones, because there was a program that gave it to you in exact form. But anyway. Okay, if you really wanted to, you can also go into solve n. So options, calc, solve n. What was it? X squared. Take 4x. Yes? Take 3? Take 3 equals 0. close my brackets. Oh, watch out, there could be more than one solution. Is there going to be more than one solution? Yes, but this will not, I don't think this gives it to you in exact, it doesn't give it to you in exact form. So that's why your polynomials is nicer. Equations, poly. Yeah? All right. Okay, so I'm going to go straight into, I'm writing the formula again, minus b plus or minus b squared minus 4ac all over 2a. Right. What is my minus b? So now it's going to be minus 6 plus or minus, right, all over b squared, so 6 squared minus 4, that's just part of the formula, times a, remember a is 1. Sometimes you do so many of these questions and a is always 1, and then all of a sudden when it becomes a different number it actually throws you out a little bit. So do make sure that if you are skipping any questions, make sure that you do some questions where you've got different values for a out the front, okay? So many people, I don't know, students just ignore the a value sometimes. Anyway, times c, which is 7, all over 2 times a, so all over 2. We're remembering that we're practicing this, trying to do it without a calculator because that could be part of your test. 6 squared is 36. Positive times a negative is a minus, so take 28 all over 2. What's 28? 36 take 28. I reckon it's 8. So we ask ourselves, is there a square number that goes into 8? It's 4, correct? So this becomes minus 6 plus or minus. Now I'm just going to do it to the side. Root 8 is 4 times 2, which means it's root 4 times root 2. So 2 root 2. All over 2. And now I can divide this one and this one by 2. So minus 3 plus or minus 1 root 2. And we're done here. You just missed some musical numbers that we were talking about, but some of the common questions that people were asking as we were working through question 1 was sometimes they might have had, I don't know, what was 1, 2 plus or minus root 33 and over 4, and they go, is that it? It's like, yes, well, 33 you can't simplify. So sometimes it's just that's as low as you can go. Not everyone will be able to be simplified, okay? So question 2 is pretty much the same as 1. It's just you have to do a little bit of work to get the equation first. So the ones that were scaring people, because I think everybody is happy that they can at least expand and get everything on one side, but the last row seemed to go, not too pleasant. Well, with this one, what we want to do is we look at this as that's technically over 1, okay? You remember, I do save this to daymap if you want. So if you don't want to madly copy, by all means, feel free to copy anybody who wants to, but I will also save this. So what we want to do here is we just do a bit of cross multiplying going on there. So the 1 times up is x take 1, and we have to then say 2 minus x times 2x plus 1, because basically we're saying let's get rid of this divide by 2 minus x. How do I get rid of the divide by? We times. What we do now is we want to expand. So remembering how to expand nicely, 2 times 2x, we get 4x, we get plus 2, then underneath, so minus 2x squared. Take x, and everything has to be on one side. You can choose, you want the left, you want the right. Nobody really cares. Where do you want to go? Get rid of the left. So go to the right. So we've got minus 2x squared. I've got 4x, take x is 3x, and I'm taking that x. So we've got plus 2x and plus 2, get rid of the take 1, plus 1 is plus 3. If this was me in an assignment or a test, I would always double check that I've done that, and then away you go and you use your quad formula, right? Also, if I was in a test and this was saying do it algebraically, I would use my solve n to pop that in and compare it with the answer that I got after. Because, you know, I know myself. Girls, you right there? I know myself, and I would probably make a silly error somewhere along the way, and you just don't want to give away those marks. So you can always double check. Okay, what about looking at H? Because then you just go quad form, right? What about H? What's the issue with that one? Yep, the divide by x. Now you should have already looked at these when we did the factorizing ones. So that shouldn't be brand new information to you. If it is, it means you have to go back and do those factorizing questions, okay? I'm not checking every single question in your book, but if you don't do the work, it comes out in the long run in your tests. Now the deal with this is that some students just times the other side by x. You have to times every term by x, so it becomes x squared minus 1 equals x. Now get everything on one side. And away you go, quad form. Okay? So we're going to break off a little bit here. Those, bless you, those who did completing the square, you can sort of carry on and finish this. The rest of us are just going to remind ourselves how to complete the square. Okay, completing the square is probably my third option. Maybe it's the fourth. Anyway, it's the last option that I would use. However, we will use completing the square later on to help us find the vertex. So it is helpful to get that process under control. So yeah, I'd use it more for finding the vertex rather than solving a quadratic. Nevertheless, what you want to try and do is get your quadratic into this form. So a perfect square equals something. Because when it's in that form, how do we get rid of a squared? You square root, so this would become x plus 5. You square root 2, and remember when you square root something, you can have a plus or minus answer. And then to get rid of the plus 5, we take 5. So this is where you have a little bit of trust in me, and if I had more time, or one that I prepared earlier, if I expanded this whole thing, actually do you want me to? No. If I expanded this, put everything on one side, and then use the quad formula, this is the answer that I would get, right? So if it's already in this nice form, you don't have to expand and get everything on one side and then blah, 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 do extra work. You can just go, let's get rid of the squared, square root, blah, blah, blah. Does that make sense? So with B, you can then go, well, hang on, can we square root a negative value? No. And we're going to look at that soon, hopefully, in a little bit, about when things don't actually have a solution. Does that mean the graph doesn't exist? No. Yeah, it's just where it is positioned on the axes. So, your job is to try and turn something like this into something like that with the brackets. Now, to do that, my tip is you need to remember your perfect squares. So, do you remember how you expand a perfect square? So let's go with x plus 4 squared. What does that expand to be? X squared plus 8x plus 16. Agreed? Right, what about if I had x take 7 squared? That would be minus 14x plus 49, correct. So then if I had x squared, let's go plus 12x, what would have to go here? 6. How did you get that? Right, you're halving that and squaring it. And so what goes in the bracket? X plus 6, right? Because, Tom, you happy? You halve this to go in there. And then you end up with this extra squared. So, when I look at this one, I'm doing the same thing. I'm focusing on, yes, I'm focusing on this bit here for now. And I'm going, what would I have to put in my bracket so that when I expand it, I get x squared take 4x? Don't be offended. Does everyone agree? Right? But by doing that, you've actually gone, that's x squared take 4x. Woohoo, woohoo! But what have you actually added on there? You've actually added on 4. So what you do to one side, do the other. So I'm going to stick the 4 there. How do I get rid of the plus 1? Minus 1. And we're pretty much done. So we've got x take 2 squared equals 3. And now, how do I get rid of the squared? Square root, plus or minus. How do I get rid of the take 2? Yeah? Once again, we look at this. As soon as I see that 6x, what do I know has to be in my bracket? X plus 3. But when I expand this x plus 3, I get an x squared. I get the 6x. But I also get a 9, which is the 3 squared. So that means I have to add 9 to the other side. Sweet? What happens to this 2? Take it to the other side. So we've got x plus 3 squared equals 7. And now? Why are you typing? I'm not. Yep, and away we go. So we've got x plus 3 equals plus or minus, now you're typing, equals plus or minus 7. X equals minus 3 plus or minus root 7. One more? Yeah, baby, because I want to use yellow. So once again, we focus on this bit here. That minus 14 is telling me what has to go into the bracket. X minus 7 all squared. But again, when I expand, x takes 7 all squared. I know I get an x squared. Yay! I know I'll get the minus 14x. But I also get 49. So you've added 49 to the left, so you better add 49 to the right. And yes, what happens to that plus 46? You minus the 46. So we've got x take 7 squared equals 3, if we're in France. And away we go. Does that make sense? The only way that they can make that a little bit crazier is, anyone? Well, I would then, have a odd number in front of the x. So that shouldn't bother us. And I bet now, let's have a look at the book. Is there going to be an odd one? Oh, they were very nice to you. Right, I'm not going to be so nice. Not nice. So, what if we had this one? X squared. Give me an odd number. 5. We'll go minus 5x. Take 7. There we go. We look. Can I factorize that? Alas, no, we cannot. So, we look at this bit here. Agreed? So what goes in my bracket? X minus, why did you put the 7 from the 14? Why did you put the 3 from the 6? Why did you put the 2 from the 4? What did you do? You halved it. So do you know what? I'm just going to go 5 over 2. I'm not going to go 2.5. We avoid the decimals. I've got the x. Did I put an x here? So people are just saying I left out the x. Don't need the x. Right, now, on the other side. How did I get this 4? How did I get this 9? How did I get the 49? It's this thing squared. Agreed? So that means on the other side, I've got 5 over 2 squared. And yes, technically it's minus, but pff. And what happened to the take 7? Plus 7. Now, remember, this could be a non-calculator question. I see the fear. When I'm squaring a fraction, what do? You square the top and you square the bottom. So this will be 25 all over 4. Now, if you're doing this with a calculator, my biggest tip, I mean, I guess you could simplify that. I'm just going in quarters. Isn't that 28 over 4? So now I've got x minus 5 over 2 squared. Is everyone happy? I've just gone 7 4s are 28. 28 divided by 4 is 7. Because you might have to do this with no calc. Okay, 28 plus 25, so 48, 49, 50, 51, 52, 53. So we get 53 over 4. How do I get rid of the squared? You square root. So this has now gone ski. When you square root a fraction, you square root the top, and you can square root the bottom. So do you know the square root of 53? No. Do I know the square root of 4? And look at that, wouldn't you know it? It's the same denominator. Who would have thought that was coming? So how do I now get rid of this? Take 5 over 2. I'm putting it on the other side. I plus. How cute is that? Damn cute. If you were to get your calculators out and go equation polynomial and pop that in, you will get this answer. I hope. If we don't, we've done it wrong. Shall we try? Ready? The pressure is on. 1 minus 5 minus 7. 1 minus 5 minus 7. Huzzah! Don't you love it when things work out? Okay, so the discriminant. We have actually already looked, you have already looked at that, because where have you seen b squared minus 4ac before? It's in your quad formula underneath the square root, right? Now, does it make sense to you that when this thing underneath the square root, when it's positive, that means you get 2 different answers. So you will get 2 x-intercepts, 2 real solutions. And in fact, 2 distinct real solutions. What does distinct mean? Different. Don't pack up, please. If the discriminant, the thing underneath the square root, equals 0, well, then what we would have, if we go back to, right, we would end up having here 4 plus 0 over 2. Isn't that the same as 4 take 0 over 2? You get the same answer twice. So that's what we call, it's one solution or a repeated root. Graphically, what does that look like? It touches the x-axis, right? So remember, all of these things that we're doing, they can have 2 meanings. One, it could just be that you're solving an equation, and so you could have 2 solutions. You could have no solution, whatever. Or we could be doing a graph, and so 2 solutions equates to 2 x-intercepts, cuts the x-axis twice. When we've got 1, that means it's going to touch the x-axis, and when the discriminant is less than 0, that means no solution exists, so no real roots. They say real because we can actually have imaginary in other levels of mathematics. It's really nice. So you don't have to do the whole quad formula. You just do the thing underneath the square root, and if you get a negative value, you go, oh, no real solutions. Your job is done. End of story. If it works it out and it's greater than 0, ha ha ha, therefore we've got 2 distinct solutions, 2 distinct real. So you need to make sure that you actually say 2 distinct real solutions, because you could have 2 repeated solutions and you could have 2 distinct imaginary solutions. So don't just think it's okay to say just 2 real. Does that make sense? Get used to the language. Hello.
Don't just get a really hideous looking guess. Yeah.
So I think all of these are pretty much same. They're going to make a surprise. You know, this one, it might be that there's two solutions. Then this one might be there's equal to 0. So I'm just asking you to do 1 and then 6, I think. Oh, no. Maybe you have to do 5 now. So 1, 5, and 6. Actually, and you might have to wait for the video for me to do 5, for 6. You never know. So this is 2B. Or not to be. So question 1, and I'm going to adjust it. You actually have to do 5 and 6. So exercise 2B, question 1, 5 and 6. I'll do a video for number 6 for you just in case, right? But hopefully you won't have to look at it.